Hello everyone, now I'm going to give you a demonstration of how to simulate this problem in ABAQUS. So first, we open ABAQUS CAE. And then we choose a standard model. Now, the first step is to create a part for this problem. So we are going to create a part first. So we choose the module part, and then we create a part by clicking this create a part button. And then we use 2D, and we use deformable as the tab, and we need to use where. And since the length of our beam is 1 millimeter, so here I put 5. So if you want to change the limb, you can change it the part of the limb as a beam. Then you click continue. And then we can draw a sketch for our beam. So our geometry is very simple, so it's a straight line. So we can create a straight line by using create a length button and right click. So you can just pick the point, but that is not accurate. Another way is to just input the point here. So our start point is 0, 0, and then hit enter. And then we input the ending point for this line, so it's 1, 0, and hit enter. So then we get this, and then we are done. So we hit the middle mouse button. So we have a straight line. And then we need to exit this mode. So we hit the middle button again. And then we click down. Now we have this, we have a part. So next part we need to do is to create a mesh for this part. So we use the mesh module. So here we are going to mesh this part using 4 elements. So we use the seed edge. So we right click seed edge, and then we need to select the regions. So we select this region, right click, and hit down. So then the question asks us to mesh this bar using 4 bar elements. So we need to use the method by number, and then we put 4 for the numbers of elements, and then we click apply, and then we click OK. So we can see we have 5 nodes here, and then click down. So next part, we need to mesh the part. So for this option, we just put some seeds, mesh seeds for this part. Now we need to mesh the part, so we click mesh part, and OK to mesh the part, yes. And then the part will turn to this color. And then we need to assign an element type to our part. So the question asks us to use a linear, so beam, linear truss element. So we need to click truss. And if we click this one, quadratic, we will use a one-dimensional quadratic element. So the question asks us to use the linear element, so we will stick to the linear one. And then click OK. So now we have we have finished the mesh module. So next part, let's go to let's define the material properties. So let's go to the module property, and then we define material property. So we call it beam material, and then we need to go to the mechanical and select elasticity and use the elastic. And then we need to define the Young's modulus and Poisson ratio. So the question asks us to ignore the Poisson ratio, and the Young's modulus is 0.001 g/. So since we are using millimeter for length, so based on the consistent unit, so we need to use the m/pa for our megapascal for our Young's modulus, so it's equal to 1. And since we are going to ignore Poisson's ratio, so we will leave it blank. Then we click OK. So then we need to create a section. So this section you can change it to beam section. And so we are going to use the beam section and truss. So then we click continue. So then we use the material we defined earlier. So we select beam material, and the cross-section area is equal to the height times the width. It's equal to 1. So we put 1 here and click OK. Now we need to assign the cross-section to our beam. So we click Assign Section, and then we select our beam, and then we click Done. Then we need to assign this beam section. Click OK. Now we have finished the definition of a property. So next, we need to go to the Assemble. So then we create an instance of our part. So we select part, and this is our part, and then we click OK. So now we have assembly. So next step, we need to define the loads and boundary conditions. So before we do that, I think we need to create an analysis first. So we go to the step. So we click create a step, and here we can create a step. So we are going to use the static analysis. So we call it static analysis, and then we select static general. So click. So here we need to use here the edit step window pops up. So we have two options. So we will keep it as it is. So, and for the incrementation, we will use the default setting, and later on we can learn how to change it. So click OK. So here you can see we have two steps. One is the initial step, the other one is the static step analysis. This is what we just created. And the initial step comes with the software. So once you open the software, you will have an initial step. If you don't want it, you can delete it. Yeah. And then next step, once we have a step, so we can create loads and boundary conditions here, or we can go to the module load module, and create a load or create a boundary condition. So since we are going to apply a body force, so this is not provided in the software. So we need to create a function to describe this relationship. So we go to the field, and we use the analytical fields and create, right click and create. So we are going to limit body force function, and then we use the expression field and click continue. And so here we need to input an expression. So the body force we have is equal to 2 times x1. x1 is the longitudinal direction. So our longitudinal direction is still x here. So we put 2 times x. And then we click OK. Now we have the relationship between the length and the load. So then we can apply boundary condition and load. So for the boundary condition, so this beam is fixed at the left end. So we just apply, so fixed end. And we select symmetry. We select the first option, symmetry, anti-symmetry, and incastra. Continue. So we are going to apply this boundary condition in static analysis step. We just created this earlier. So click continue. And then we can select this point, right click, and then click down. So when the edit boundary condition window pops up, we need to pick incastra. So it's completely fixed. Click OK. And next, we need to apply a load. So we only have one load, which is a body force. So we apply this force in static analysis step. And we have body force here. So we select body force and continue. So then the software asks us to select the bodies for the load. So we select this body and click OK. So for the first component, we need to put 1. If we put a negative 1, so the body force will flip its direction. So we put 1 and click. So here we need to use the function that we defined earlier. And then we put 1. It means the body force will along the positive of x direction. Yeah. And click OK. So you can see the body force is increasing along the longitudinal direction. Now we have everything. We have material properties, we have mesh, we have loads, and we have boundary conditions, and we also have assembly. Next, we need to create a job. So create a job, and we name this is beam under axial load. So we click continue, and then when the edit job window pops up, we just use the default option, click OK, and then we have a job here. So until now the software doesn't do anything. So we need to submit the job so that the software can start running the static analysis. So let's right click the job that we created and left click submit. So we can see here when we submit this, the status is showing here. Now it's running. So if you want to check its status, you can check it here. So it says running, and we submitted at this time, and it started input file processor, and now the job is done. You can see that we have only one step and one increment, and the loader is completely applied here. So the status also shows completed. Now we can check the result. So we can go to the results. So we right click and click the results. So if we want to check the deformation, we can click this button, plot deformed shape. So you can see it's elongated. And if you want to check the stress, you can click this button, plot contours on deformed shapes. So let's compare the displacement at each load with the exact solution. So I'm going to check the displacement. So I click this button, and then we can check. We need to go to Tools, Query, and then we check the displacement of the load. Then we need to select each load. So this is completely fixed. So we will start from the second load. So the second load is let me check. So we are going to check load, and you need to click prob values. Oh, now let me check. This is the first load. So let me check where is the second load. So this is our fifth load. So this is our fourth load. So our third load should be nearby. Let me check where is the third load. This is our third load. So we have one load left. It should be nearby here. Okay. Left click this load. So we can see that so the displacement all shown here. This is our second load. This is our third load. This is our fourth load. This is our fifth load. And you can see when you submit your job, the status will also be printed here. And when your job is completed, you can also check here. So let's compare with the exact solution we have here. So for the second load, we have 0.244. And for our second load, we have 0.24. So for the third load, we have 0.458. And we have 0.453. And for the fourth load, so we have 0.609. We have 0.601. So for the fourth load, which is 0.667, and it's the fifth load in our model, which is 0.656. So it's pretty close. So in our model, we start our first load is here. And when we calculate the exact answer, we start load. This is our load 1. However, in the model, this is our first load. You can see it's our first load. Okay. So if you want to check the stress, you can check here. And in order to check stress, you need to use query and prob values. Then you can click each load to check the stress. For example, if you want to check the stress at load 1, so you click, or you have to click the element. So you can see this is the stress. This is the stress in the first element. And this is the stress in the second element. Yeah. Okay, that's all for today's demonstration. Thank you.